Hello, welcome back. Today, let's try to solve another Leetcode problem. This is also from the daily challenge 2616. Minimize the maximum difference of pairs. Let me first explain it in whiteboard and then go to the code editor to finish the coding. Now let's just go to the whiteboard first. So as I said, this is a binary search problem. Now let me just explain it in the PowerPoint. So for this problem, I'm going to use binary search with brute force. So this is also a typical problem. It happened a lot in Leetcode problems. So we are giving an array nums. So nums, they are random positive numbers. It can be a 0. And also we have a pair P. P means how many pairs we have. And the output 1 means the maximum of the minimized pairs. The minimized pairs means, for example, P equals to 2. It means we have two pairs. 1 and 1 is a pair. So the minus of 1 by 1, it is a 0. And another pair is 2 and 3. So 3 minus 2, it is a 1. So the maximum of the 0 and 1, it is a 1. This is why we have the output 1. So for solving this problem, we normally need two steps. The first step is what if we know the result? How to check it? For example, if we know the result is 1, so how should we check? How should we prove that it is 1? For example, the output here is 1. So how can we check it? For checking the output of 1, we have to sort the array first. After sorting the array, sorting the array is a greedy idea. So after sorting array, we have array of 1, 1, 2, 3, 7, and 10. So how can we prove that there are only two pairs? We can prove that easily as we can see that. So the first one and the second one can be a pair. So the minus of 1 by 1, it is a 0. So it is a result because 0 is less than this 1, right? Because if we already find a number 1. So what about another pair? It is a 2 and 3. So 3 minus 2, it is 1. 1 is less than and equal to 1. It's another pair. So in this step, we have two pairs. So if we have already found two pairs, it means at least 1 is the answer. So this proves how can we, this proves if we find a number 1, this proves the 1 is our result because we can find at least two pairs because P is 2 and we already found two pairs. So the second step is how to find the result. The result means the output. How can we find the output is 1? Here we can use enumeration, but for enumeration, normally we can check 1 by 1, like from 0 to 10 to the power of 9. But this really takes time. As we already know, the Leetcode cannot pass this kind of time complexity. So we have to use a better algorithm. So the binary search comes into mind. So if the array has already been sorted, but the array is not the nums. The array is from 0 to 10 to the power of 9. Because the maximum number is 10 to the power of 9. But we should also know that the maximum number actually should be the 10 minus 1, for example here. So it means the nums minus 1 minus num 0. In this example, the maximum can be 9 because we cannot find a number. We cannot find a pair that is the minus of 1 by another is bigger than 9 for this example. So it means it cannot be 10 to the power of 9 and it can be bounded to 9. So for this one, we're going to check the minimum of 10 to the power of 9 to 9. So actually, we just need to take this 9. So what is this 9? It is the maximum of the number minus the minimum of the number inside nums. Now let's just go to the code editor to finish the coding. Now let me go to the code editor to finish the coding according to my ideas. As I said, basically I'm going to use a binary search to solve the problem. And before the binary search, I'm going to define a function check. So inside I will take a threshold. And then here I will make it a pass for the function because I'm not going to write it yet. I will write it later. Now I'm going to use the binary search. So for binary search, I need two variables. L means left pointer and R means the right pointer, and I also need a result. So the L pointer should be 0 and R pointer should be nums minus 1. It's the biggest number, and minus the nums smallest number, it is 0 because nums has already been sorted and the result is 0. But before that, we can sort the nums first. Here we can sort the nums first, and then we should know that the L should be 0 and the R pointer should be nums minus 1 minus nums 0. It means the biggest number minus the smallest number, because anyway we need to have the absolute value of any two nums. So this means it is the maximum number. So what we are going to do, we are going to use a binary search to check from the minimum to the maximum numbers and which number meet the condition. Yeah, if this number meets the condition, we're gonna check, can we try to find a smaller number even? If the smaller number even meets the condition, so what we're gonna check so the result will be that smallest numbers. Yeah, this is why we also need a result. So finally, we're gonna return this result. Yeah, but before returning the result, we just need to use binary search to check. So for L less than and equal to R, we're gonna have a M. It should be L plus R minus L divided by 2. So this is the mid number. So if this number, we can use a check. If check num, so this check num means if we can find this number meet the condition of this threshold. Yeah. So for this threshold, we're gonna check if we can find at least 2 pairs. Yeah, for example, if P is 2, we can find at least P pairs. Yeah. Now, if this check is right, it means we've already found M. So it means this M already meets the condition. So what are we gonna do? So the result should equal to M. But it's not yet the result. We have to let the R pointer equals to M minus 1, because even we find a number, it can be a smaller number meet the check conditions. We have to try. Otherwise, we're gonna use L pointer equals to M plus 1. If we didn't find, we're gonna try to the next point. What is the next point? It is M plus 1. Yeah, it is the next number here, I mean. Yeah, now we're just gonna to finish the check function. As I explained the check function, we just needed to use the brute force to finish the check. Now let's write the brute force of check. So here I'm gonna need two variables. I means the index and count means how many pairs. So from the beginning, I equals to 0 and count equal to 0. And then I'm gonna use the while loop. So while I plus 1 less than length of nums. So while it is less than the length of nums. So here I use I plus 1 because I'm gonna use nums I plus 1, because I plus 1 is always bigger than nums I. Yeah, but we need to check the threshold. If it is smaller than the threshold, yeah, if it is smaller than the threshold, we can count by 1 because we already found a pair. So here we're gonna count plus 1. And what about I? So I should plus 2 because we've already found a pair. Yeah. Otherwise, so the I should plus 1, because if we didn't find, we're gonna go to the next step. For example, yeah, let's go to the PowerPoint. For example, here 1, 1, 2, 3, 7, 10. So 1 and 1 is a pair. It means we've already found a pair. Yeah, 1 and 1 is a pair. We've already found a pair. Then we go to the next pair. This means we're gonna use I plus 2. Yeah, if we didn't find, for example, from here, yeah, 2 and 3 we've already found for this output 1. Yeah, and what about the next step? Yeah, next step we didn't find, so we're gonna use this 7. It's I pointed to 7, it goes to I plus 1, it goes to 10, because it may have another pair. Maybe the next is 10 or 11, it can be another pair. Yeah, so this is why we're gonna use brute force to check one by one. So here it also comes why we have to use brute force. Can we prove that is right? We cannot prove that is right, but we can use counter examples to prove that this is the optimized solution. For example, if we have a number of 1, 2, 1, 2, 1, 3. Let's use this example. Can we find two pairs? The maximum result is 1. We cannot, because if we use 1 and 2, what is that? The result is 1. It is okay. But what about the next one? Next one is 1 and 3. 1 and 3, the maximum is 2, because this is 2, this is 1, and the maximum result is 2. So it means it cannot meet the conditions of the result 1. This means this idea didn't work. So in this example, it means we have to use the greedy to compare how many pairs. For example, this is the first pair, this is the second pair. Now let me go back to the code editor to tag. So here we use the tag. So what about the final of the tag? How can we prove that is true or false? So we're gonna use a return. So the return is use count, how many pairs. If the pairs is more than and equal to p, this p is the pair from here. It means this number is still okay. For example, the minimum, for example, it is 2. If we find more pairs, it means 2 is still okay. So what about we try the smaller number? It may be 1. And for 1, we still can find it. So the result will be 1. But continued to the next, if it is 0, we cannot find. So this means the result would be 1. If it is 0, it will go out of the loop. Now let me run it to check if it really works. Time limited, it means something wrong. So let me check. So this is the L and R, result is 0, the M. So if we check M, the R should be M minus 1. L should be plus 1. And nums.sort. Here we should use here we should use nums I plus 1 minus nums I less than and equal to threshold, because this is the definition of the problem. It is not less. Now let me run it to check if it really works. Here I used I should plus equal 1. Now let me check. As you can see, it is right. So sometimes it's annoying because when you write the check function, there's some syntax error, but it didn't tell you. For example, this I1. But finally it works. Now let me submit it to check if it can pass all the testing cases. As you can see, it passed all the testing cases and it's pretty fast. So the time complexity is O n log n, because here we use the sort. So for sorting of the nums, it is n log n. So the n is the length of the nums. And for here, for the binary search, here is another check. So for this binary search, that is, for example, the biggest number is 10 to the power of 9. So the log 10 to the power of 9, it can be a bigger number, maybe 30 or 40, but it's not so big. And then here, we use the tag. So for this tag, actually the maximum can be on. For each time it's on. So it is like 30 times times n. But for this one, it is n log n. So basically, they are the same, and even yeah, maybe this is even smaller, but here maybe bigger. So what do I mean? I mean the result is n log n. It is okay. Yeah. Thank you for watching. If you think this is helpful, please like and subscribe. I will upload more Leetcode